the process of compiling the results from the two sets of polls, the pre-poll and the post-poll. And as soon as side-by-side compiled, we'll put those up and also ask at least some of our panelists to reflect on what they've seen, the developments that sort of get exhibited by those responses. And so with this, I just want to open up the floor to any questions that you might have or any comments. If you could raise your hand and we'll get a microphone to you. If you then also could introduce yourself once the mic's there, I would much appreciate it. Thanks.
Hi, my name is Will Walker. I'm a PhD student at Eastern. I'm taking this class. One of the things that always kind of comes to my mind when people start talking about geoengineering, they start talking about some of the dramatic interventions that are being considered and discussed. How do you guys who have these conversations justify engaging in these interventions, and they're usually very costly sorts of things, not impossible by any stretch of imagination, but neither would dramatic reformative interventions in, for example, the power industry. Like for the cost of some of these systems or these solutions, you could plop down all kinds of power infrastructure using these renewable technologies. How do you have a conversation with someone where you argue for one of these interventions instead of that sort of shift?
Let me just start on the technical front on this. I think one of the things that's important to absorb is the very different orders of magnitude of investment cost. When what John and I were talking about, stratospheric aerosol injection, we put numbers on it, about $1 billion a year. $1 billion a year is not an insignificant sum of money, but it's practically a rounding error to the US budget. When you think about the amount of investment, Armin will talk about, give you some figures in terms of what it would take to actually invest in building new energy infrastructure. But we're talking hundreds of billions to trillions of dollars in investment over the next 50 years. So if you think about 50 years of investment costing trillions to many trillions of dollars versus $50 billion, you're talking about 3 orders of magnitude difference, which is precisely why the incentive structures for countries or for corporations or for a bunch of vested interests may end up drifting towards, well, hang on a second here, if this costs us so much less to do this, why not do this rather than invest in? And the reason why I think this conversation is so important to have is because there are risks, there are unintended consequences, but the costs are significantly less, and the ability to deploy it quickly, and overhauling the energy system is a 50-year proposition. Cooling the climate with stratospheric aerosols is a 1-year proposition when you decide to do it. So the real issue is what do we put in place to decide and make those decisions more effective? But it's important to get those costs. They're very different in magnitude, and that in and of itself is the key difference when talking about geoengineering.
Let me add to that, though. You've got to get the consequences in there too, and it is true that there's very high leverage here. Putting these particles in the atmosphere give you very high leverage over the climate. However, it doesn't alter the underlying global warming phenomena at all. It just counterfeit. Okay, so it's still, and I frequently say that it's the equivalent of heroin addiction, actually, and equally irresponsible, unless you accompany it with a commensurate amount of mitigation. And I think that rule is likely to emerge as you talk about what are these vetting or rule-based institutions and procedures going to do. That's going to be, I think, one of the things that let's hope that they do. Whoever proposes to do any solar radiation or any climate engineering of this sort has got to accompany it with a program of mitigation that has comparable effect. Otherwise, it's extremely irresponsible, because you can never stop it, the global warming start, and then you're likely to actually change the climate dynamics. So we need institutions can work out the details of that and to impose these very obvious rules. And otherwise, the temptation is, for the cost reason, is going to be very great.
Yeah, I just want to offer a data point. So exactly on your point. So the global electricity bill right now is somewhere around $2 trillion. So if you do, the numbers I showed you, if we're going to do it, if we're going to go all solar and wind with current technology, we're probably talking about tripling that cost. So maybe we're going from 2 to 6 trillion. $4 trillion is something the world economy would miss. Several billion is not something the world economy would miss. Over time, but I also want to agree with you in some sense, the premise of your question, where you're going with this, which is that if we can come up with better technology, I mean, you probably took from my view that I tend to think the centralized baseload technologies are going to have the advantage from a feasibility standpoint. If we can get the nuclear plants, advanced passive safety modular nuclear plants down to within spitting distance of the cost of a new gas plant or a new coal plant, then you're absolutely right. Once we're through the valley of death, then it doesn't cost you anything, right? Because you're not spending any more for the clean stuff than for the dirty stuff. I think the challenge really is that period of R&D and scale up, and can we even get to the other side? The whole point of my talk is I think that's going to be a really rough sledding for several decades to manage those costs down, if we ever can. And if you can't, then I think you really are stuck with just damage control.
Just one other thing that I think both of us regret not harping on it. You put sulfate particles in the stratosphere, they come out and they go into the ocean, and you're talking about ocean acidification which is going on anyway, increasing the rate. You're messing with the entire food chain. Okay, that's a big deal. Again, when you're talking about these institutional procedures, who has the burden of proof? And about what do you have to, and I would say that you're going to have to demonstrate, if you want to do a geoengineering technique, that the net benefit is decisively greater. And I think that burden of proof is going to be very hard to meet.
A quick comment on that last thing. Some sulfate particles come down inland and people breathe them in. I think we've got about 500,000 people so far dying per year from sulfate that go up. I read, sometime less than a week ago, and I wonder if Armand and Holt heard this yet. I found some things. My daughter had a friend in high school whose parents were from China. She was in Lexington, Massachusetts. She went over there on an orchestra tour, and she was hospitalized from breathing problems, basically breathing the Chinese air. And it's gotten worse since then, and Politburo leaders are having difficulty breathing the air. The article I read, it's in the general press, had a couple of things to say. One is coal is getting unpopular in China because of breathing problems. They're talking about putting on a lot of filters, which I don't know, probably means baghouses. The article I saw said filters. The other thing, which I think was in the same article, was that in 2012, I found this really striking, that more terawatt hours were generated in China from new wind installations than were generated that same year from new coal installations in China. And there's certainly, there are plans to build 200 gigawatts, I think, of wind power. A lot of it Inner Mongolia, Xinjiang, and so forth. And I'm wondering, are you aware of those? If you haven't, what kind of reaction do you have to that news about China? Can you expect anything similar from India, where government leaders are going to have difficulty breathing the air in their brown cloud?
Let's separate two issues. There's air quality and there's CO2, and they are different issues. You can solve the air quality problem for China coal use for scrubbers. They're doing a lot of that, actually. The real unabated coal that's, by the way, about 20% of the particulate matter in Beijing is from coal. The rest is from automobiles, trucks, and so coal isn't actually that big a deal for Beijing. But you can deal with coal power generation, particulate matter, and the health effects through pretty cheap fixes. And in fact, China is building sulfur scrubbers on almost everything they're putting up right now. So that's a diminishing source of sulfur. It's a huge source of CO2. Now on scale, of course I'm aware of what's going on there. We have an office over there that tracks this pretty closely. So you're right, China is aiming for 200 gigawatts of installed wind capacity by 2020. Now the capacity factor, if you adjust that on a capacity factor weighted basis, it's about 33%, capacity factor, you're down to something like 70 gigawatts of effective or coal equivalent wind. China's planning to have 1,200 gigawatts they right now have 600 or 700 gigawatts of installed coal capacity, and they're going up to 1,200. So you do the math. Yeah, absolutely. They're going to do everything. They're going to build all the wind they can. They're going to build all the nuclear they can. Still isn't going to hold a candle to the amount of coal that's already up, and it's going to be running for decades. So look, I'm not dissing wind. I'm not dissing of energy efficiency. I'm not dissing solar. I'm just saying scale. Power density. Those are big issues. If you take, I'm just saying, if you take the nuclear or you take carbon capture off the table, you're saying, okay, we can do 200 gigawatts or 70 gigawatts equivalent wind, but you got 10 times as much coal that's being unabated. It's just an all of the above argument, really.
Yeah. And it's important also in terms of air pollution and climate change. This is an issue that the integration of both cleaning up the air for people to breathe and dealing with climate change simultaneously is going to be one of the major policy issues for the next decade or 2 decades. But it's important to get the numbers right and to really understand what it means. Let me deal first with the geoengineering side of things. The amount of sulfur that would be put up in order to cool the planet in the stratosphere and then come down is less than 1% of the amount we put up in the troposphere right now. The amount you put up in the stratosphere would have no effect. It actually wouldn't have an effect on ocean acidification either. CO2 dwarfs it on ocean acidification. The point is, by cooling the climate, by putting stratospheric aerosols up, you don't reduce the amount of CO2, so CO2 continues to acidify the ocean. That's the main acidification. But in terms of air pollution, putting the sulfur in the stratosphere doesn't add to air pollution at the ground level. It is within the error bars of what we measure. But one of the important things to keep on this sulfur issue, and this is one of the most pernicious challenges we face, sulfur, I explained how sulfur in the stratosphere acts like a little mirror and reflects sunlight away. It also does it in the troposphere. If we eliminated right now all of the sulfur that gets emitted along with coal and fossil fuels, we would warm the climate system up. We would warm it up potentially quite significantly. There's a lot of uncertainty right now as to just how much cooling we get, but it can be anywhere between about 20 to 30% of the CO2 warming being masked by sulfur right now, to something closer to 80% of the warming being masked right now. And as they cleaned up sulfur in Europe and in North America, you do see trend, you do see that impact on the warming trends within Europe and within North America. China and India right now have that sulfur as a mask, and once that gets removed, there are trade-offs. How do you deal with that? How do you deal with that? One proposal has been stop putting the sulfur down below, put 1/100th of it up top, keep the energy balance the same. But that's geoengineering. But as we make these decisions about how and where to reduce air pollution and how and where to reduce it, not just on the cooling aerosols like sulfur, but on warming agents like black carbon, which we haven't really talked about, but it's basically soot, we're already starting to make regulatory choices about energy balance of our planet. We're already doing geoengineering. We're starting to do the engineering of our radiative balance in our regulatory systems on when the scrubbers get turned on and off, how much sulfur do you have in fuel for seagoing, for ocean liners and things like that. These are decisions that as we understand the climate system better, we're doing these calculations are starting to figure into regulatory systems. Geoengineering isn't just about all the fancy technologies and the science fiction. It's also about how we set up our governance, how we set up our regulation. We've got to make these choices no matter what we do. We just better be a damn lot smarter about them than we've been over the last 40 years. And now we have the science. The trick is how do we integrate the science effectively into the regulatory mechanisms, into the governance decisions. That's the tough bit.
All right. Right, many thanks. Let me just very quickly come to our pre-poll and post-poll, and then if there are any sort of closing comments, I'd love to hear them from the panel. So go ahead. So what we have here, side by side. So the first question basically asked you to compare your perception of the risks of geoengineering with those associated with climate change. And coming into tonight's presentations, there seem to have been bunching around sort of the middle range here, where the majority of people either thought that it was greater or roughly equivalent, the risk of geoengineering versus climate change, and then this could all somewhat spread out across the different categories, potentially as a result, I would think as a result of the presentation. So now many more people see greater risks, but also many more see smaller risks or equivalent risks. So let me move on to the next, which then compares the geoengineering solutions and asks, where do you see the biggest impacts going to be? Are they going to be environmental? Are they going to be, let me see, associated with misuses of the technology from nations or corporations? About roughly the same going into this. Fewer people thought that the issues really are with the behavior of individuals or corporations or governments, and those numbers shrank and moved into the extremes, if you wish, where either the unintended environmental consequences were considered larger. Well, actually, no, they're somewhat smaller, but then mostly people thought they were roughly the same. So I'm curious to see, what your perspectives are, from our panel on this. And then last but not least, how far down that list of different intervention strategies should we move? And previously, sort of most people would have stopped at medium-scale, small-risk field experiments, and that kind of is more or less the same. And then across the categories, there are some small changes, but it didn't look like coming out of this set of presentations, you felt like, oh yeah, we're gonna hold further back than we could, or go further than we anticipated we could. So, Jason, John, any quick sort of reflections on this? We have about 2 minutes to wrap this here up.
Yeah.
Quick reaction. We haven't explicitly said the issue here. Jason is making a point that we're going to need governmental and procedural institutions to deal with this, and he's certainly correct about that. And the underlying issue is going to be a balance of interest, local, national, global. And it's just going to be very difficult because we have political institutions that do not do well with global interest. And we're going to have to learn to do better than currently do.
I think the one reflection that I have from this poll in particular, this last one about what level of research to do, is when you start thinking about what sort of experimentation you'd be comfortable with and allow, you've classed it here in terms of low risk, medium scale experiments with low risk. What does risk mean to you? What does risk mean to different parts of the population? What does risk mean when you spread it around the world? John talked about the fact that we need some sort of a global framework for almost a permitting system. If you want to do a low-risk experiment in geoengineering and SRM, who gets to make that decision? Who gets to set the processes in place? These are the sorts of things, it's just echoing what John was saying. It's about how we set that structure up and make these decisions. And it's not unique to geoengineering. Those of you who have followed the global climate negotiations, we've been having the same conversation for 20 years, and at the last big meetings, they've agreed to take another 5 years to see if they can figure it out this time. It sounds familiar. And so the innovations, as far as I'm concerned, as difficult, Armin did a great job summarizing a lot of the technology challenges associated with the energy technology and the economics. As far as I'm concerned, we have a lot of technological capacity to innovate, and we'll be fine on that front if we get the social structures right, if we get the governance right. That's where the real tipping point has to come. Armin was saying, we can, if we really push, maybe come up with new technologies that push the barriers. But where's the investment? Where's the social structure? Where's the decision-making processes? That's the real challenge.
My closing comment is, if we took nothing else away from this talk, at least from my talk, I would say, let's admit that we're geoengineering the planet right now. We're just not doing it deliberately. And next time you're in a conversation about energy and someone says nuclear power is off the table or carbon capture and storage has too many risks, let's just put this in a comparative risk standpoint or perspective, and just read up on that, because I think there's a lot of, believe me, I've been in the green movement for 30 years as a professional, and it's very hard to have these conversations, but I think we have to have them. So I encourage you to be open-minded. Although I gave you a somewhat depressing talk about the challenges, I also think, and I could have given you examples of where we have moved technology pretty quickly from almost nothing to say 20% of global energy share, or at least electricity share. So it can be done over a period of decades, but it will take a lot of money and it will take a lot of time.
Well, on this somewhat optimistic note, I want to thank all three of you for your wonderful presentations. And I do want to thank all of you for being part of this. I did want to, and I did already alert you to the fact that there is no open classroom next semester, so this was our very last presentation. Next week, sorry. And then next semester, we'll have a different topic, and Dean Fitzgerald will talk a little bit about that.
Okay, I'd like to thank you all as well for attending. I know from my own perspective, we've learned a lot this semester. One of the interesting things is almost every time we get some very depressing lectures, and then they try to come in at the last minute and give us a positive note, but this certainly is a very daunting issue to deal with. And we're moving into another one next semester. In the fall, our topic is going to be Policy for a Healthy America. And we've got great leaders for this course. We have John Arbach from the Bouvet College of Health Sciences leading it, Tim Hoff, who we just hired in the policy school. He's in the business school as well as in the School of Public Policy, and Wendy Parmet from the law school. So we're going to get a whole university-wide perspective on what it takes to create policy for a healthy America. So tell your friends, come back in the fall. We hope to see you all then. Thank you for attending.